Welcome back.
Sorry, I missed the start of the beginning of the pause. So
The beginning of what?
of the break.
Oh, you did. Okay. Well, we can take another break if you want.
I
No.
don't know. I went 2 minutes and I came back and everyone is offline. So offline. So
Okay. So you can look at it differently. You had a longer break.
2 or 3 minutes more. But now I will need to listen to the recording, and this is the
Yeah. Yeah. I
last
think
recording.
that recording is important. Just to understand the landscape of TCSC. It was very important. I think
So,
there were some good discussions there. So highly encourage this. All right.
Thank you.
Okay. So yeah. Any question,
just
Al?
yeah, just regards to the recording and the files that you've uploaded, I can't seem to download them.
Oh, you can't seem to download them. Okay. Let me find a way.
I
Uh,
think
Yes,
it
yes.
might be that your team's organizational settings is set to not allow external.
I think it will be a permission issue. I think.
Yeah.
yeah. All right. Well, I'll figure it out. Don't worry about it. But I'll figure it out and I'll share those recordings with you. No worries. All right. So
Thank you.
the next topic, we're still in domain 3. Okay. We're still doing some security engineering. And security engineering, as mentioned before, mentioned in the beginning of domain 3, is all about controls, designing controls. That's why cryptography is a big one because it provides confidentiality and integrity. We also looked at the trust that we can build using the right controls with our potential customers. And the highest demand in security for customers is, resides with the DoD and everything that comes after. And we also talked about the trust when we talked about digital signatures, which also create trust. The different access models, basically access control in the base of everything in security. But now we're going to talk a little bit about the way the conceptual threat for our applications and software, and the way we manage our data, or the way we use the data. So the first one, sorry about that. Again, my video stopped for a second. The first part is to look at data inside that collection of data, which we call database. Okay, so a database by itself is something that is helping us, do things more efficiently, make decisions from a more strategic point of view. But a database by itself is also a huge vulnerability for the organization. And the reason behind it is that it's basically a collection of a lot of data. So if someone puts their hand on our database, or if someone can build from that database a lot of information that is useful for them, then we can be perceived as negligence, and the fault will probably be on us. So databases by themselves have ways to be structured and be managed. And today, most of what we are focused on is the relational databases. So relational databases is the latest concept behind the database in general. And RDBMS, Relational Database Management System, is what we are most likely to work with. Also for databases, we have what we call data warehouse, which is kind of similar or reminds us the way database actually works, but this one is for what we call today big data. So big data, or what we can refer to as metadata. Okay, so we basically build data about our data. So we collect data about all citizens in Germany. Okay, all residents in Germany, which is an immense number of people with immense number of records and details in those records in our database. So how do you manage this? How do you really approach these databases? You need to collect information about your information. You need to build logic behind the data. And again, this creates for us, the CISSP, the security professionals, creates a challenge on security, because this now becomes an asset that we have to protect. Okay, so what do we want to protect? What do we want to provide in this database? First of all, we want to make sure that it's accurate. It's accurate. The integrity part, the secrecy behind it, confidentiality, the level of clearance people have in order to access that database. So basically, the CI and H of the database are concerned when we address that. However, we as the CISSPs or CISOs are not the one to actually act on it. So if you remember, there is an owner, an asset owner, data owner, okay, and we have the custodian. Our position is to be a consultant. So somewhere in between, we connect the owner with the custodian. The custodian, for that matter, is the DBA or DBMS, okay, the person that manages the database. That will be our custodian, and that will be that person that we want to go to in order to get the maximum level of security required for our organization and required for the operation of the organization. Some of the threats, vulnerabilities and threats we're looking at when we look at database, and we will go back to databases when we talk about, when we cover domain 8. Okay, so databases are the beginning of domain 8 as well, chapter 20 in your book. So threats and vulnerabilities of databases, and we will cover this in more depth later on. The first one is aggregation, data aggregation. Data aggregation means that I now collect data from the database that I'm allowed to have access to. I do have access to this data, but I don't have access to all the data. Let's say I work as a teller in bank. Okay, I work with the customers. They come in, and every time I work with one customer. So my computer or my system is designed in such way that I will be able to have on my screen only one account per transaction, okay, per customer. So I can only serve one customer. However, this is very annoying to me, bring up this record from here and then shut it down and then bring that record and say I'm trying to work with two customers, husband and wife, each one of them has their own account. It's kind of a hassle for me to have to close this account and then open that account and then write something on the paper. So what I do is that I copy the data or I print out the data for myself, and now I have the two accounts in front of me and I can serve both clients. This is a business need that requires me to violate the policy, because there's this policy that says I can only access one account at a time. So the business need is not lined up, or the security definition, security requirements are not lined up with the business needs. Okay, and this happens all the time. So for this vulnerability, we have the threat called data aggregation. That means that the user now collects data, and build their own database based on the data that they have access to. Okay, this can be the problem of organizations that don't align security requirements with the business requirements. There is this extended problem of data aggregation, which we call inference. Inference is something that is more related to fraud. Okay, so let's say the same clerk, the same bank teller, they sit and they have access to the database, but what they do now is that they make assumptions on the data. So they build a database based on the information they think they understand from the existing database. Does that make sense? So say I have access to all customers in Berlin. So I assume that those customers are mid-age, working people. They have at least one saving account. I don't know that from this database, but I.
So
okay.
It's basically deduction, not deduction, induction.
Induction, I'm not sure.
No, you deduct the
Oh,
information
deduction.
from the data you have. Sorry.
Yes, yes. So yes, but you also build your own database. So now I have database with my data, but also other types of data that I didn't intend them to have, but they do have it because they have access to my data. Okay, this is more of a fraudulent.
Okay.
It's a more of a fraud-related action. Okay, so aggregation can take place by mistake, by not having the same line of security and business needs. So these type of questions you can expect in the CISSP. And inference is someone that is actually trying to do something bad because they have access to the database. Okay? And the controls we have for inference are all the controls that we previously saw. Let's start with the need to know and least privileges. Those are the first two that we talk about when we talk about access control. And then we talk about the availability of that database. So in databases, we have what we call shadow copy, or shadow of primary database, okay, and a failover. So this will contribute to our database. This is what we call fault tolerance of the database, okay? So that availability, we need to build a shadow copy. We need to have a failover, and this is relevant for every database that we can think of. Let's start with the domain controllers. The reason we have two is exactly this, okay? To have another copy of the Active Directory and to have another authentication machine that people can use, you know, and we're not necessarily dependent on just one. So the baseline for Active Directory for any Microsoft network is to have at least two domain controllers, right? And I can think of any other databases, Exchange and any other databases that will probably use part of these. So this is the database part. Any questions on this? All right, let's move on to other software and applications. We have, in today's world, we have what we call applets. Applets are small applications, okay? They're written in Java. And Java by itself, you know, coming from Oracle House, Java by itself brings a lot of vulnerabilities by itself. And why is that? Why is Java so interesting for hackers than anything else? Do you have any idea why Java is you know, more interesting for hackers? What's the problem with Java?
You can run scripts within Java.
Come again?
You can run scripts within Java.
You can run scripts, but you can also run scripts on command line. That's true.
But for instance, so
It's an open source, right?
What's that?
It's open source, right? It's open source, right?
Open source.
If you ask what's the problem with Java, is that it's old.
It's old.
It's super vulnerable all the time.
I'm not hearing anything unique so far. Everything you said is right, but it's not unique for Java.
So the thing is, like, for instance, with Java, and like I know with certain browsers, for instance, well, all of the browsers except your Tor browser.
Now you're talking, man.
So for instance, with when you run a Tor browser and the browser is not full screen, so it's half the screen, then Java cannot run in the background of it.
All right.
So
Let me direct you on Java. Java is a cross-platform. Hang on a second. Sorry about that. It's a cross-platform application. That means that Java can run on any computer, any operating system. It, quote unquote, has its own operating system. It can run on any browser. You don't need a certain browser with a certain version to work in order to have your Java work on. You can run Java everywhere. Yes, there will be requirements, and you probably experience that online when you go online and it says your Java version is not the right one. This is where you want to have the Java part that actually writes to the application. But the applet itself, the small application written in Java, it doesn't require anything. So I can run it on any platform. cross-platform application. And that's the beauty and danger in it, okay? Because a malware or a malicious code that is written in Java is not dependent on the platform that it runs on. It can run on any platform. You see that? So remember this about Java, and when it says applets, applets talk about Java, and Java brings this vulnerability by itself. Clickjacking is when someone is trying to hijack our clicks on our website. It's a vulnerability embedded in some websites that we still see today. And this one helps promote other websites that are not mine, okay? So if my website is vulnerable for clickjacking, I would probably get that indication from just running an OWASP top 10, and we will talk about OWASP top 10 in chapter 21 in domain 8. By running an OWASP vulnerability scan, the simple one, I will probably get the indication that my website is vulnerable for clickjacking. So in order for you to experience the clickjacking, we sometimes experience websites that call us to turn off our antivirus, turn off the firewall, turn off your pop-up blocker. You probably experienced that. Okay, so these are all indications of potential clickjacking. Cross-site scripting says that means that some website is vulnerable for the implementation of a script or code in it to make traffic go to another website. So it's not clickjacking, it reminds clickjacking, but cross-site scripting means that you work on one side and then on the background you have another side that is connected by scripts with that website. And the problem starts with the website itself, okay? There is the twin brother of cross-site scripting, which is CSRF, cross-site request forgery, which starts with the vulnerability on the browser of the user. So this one is the server, the other one is user. Okay, we will talk about that when we get to the OWASP top 10. The way to handle most of the vulnerabilities, the web application vulnerabilities, starts with input validation. So think about it. The websites that we work with are the front end of something that works in the back. In the back, we can have a database, okay? That database, we treat it as an object. It's passive. Every request that comes from the outside, okay, it needs to fulfill it. If the request comes in and say, give me the record you have on Chen, the database will reply to that website saying, here's the record of Chen. If the next request will be, give me all records you have, the response will be, here are all the records we have. The database is an object, okay? The website is the subject now because it addresses the database. So for the website to be a subject, it now becomes a target for hackers, okay? They target the subject because they want to use the rights, permissions that that website has on that database to get access to get information pulled out from the database. Okay, makes sense? All right. For us to be able to protect or to provide the least protection on that website, we start by implementing certain controls on the way the website is communicating with the world or is available to the world. First, we can say, okay, this website is not responding to any call outside Germany. Boom, we'll limit the population, we'll limit the attack surface of that website, right? Remember the attack surface? We'll limit the attack surface of that website. Then the other part will say, okay, I want to allow people from outside Germany to log in, but people from outside Germany will need to work during German time, okay, Germany work time. So people from Japan, for example, from Australia, will need to consider Germany's time in order to use that website. But we most likely we would not do that because it reduces traffic significantly and it can affect the business requirements. So what can we do with this website? The first and foremost thing that we can do is be able to control or limit the attack surface through the input mechanisms. Okay, For that, we have all the fields that the user of the website can communicate with everything that is behind the website, and those fields will be the fields of the input. They will get the order from the user. Or, okay, what is it that you want? I want all the records related to Chen. Okay, I'm going to go to the database and then pull out all the records related to Chen. But what if that input mechanism is vulnerable to scripts? So let's say that user doesn't enter, give me all the information about Chen, or put in the username Chen Hefel. Let's say that user puts in John Smith, and we don't have John Smith on our website, but it says, if you don't have John Smith, then give me everything else you have. If the database gets this type of request, it's simply, do you have John Smith? No. If you don't have just John Smith, then bring everything else. And this is the action that the database will actually take with the web server. So the control needs to be on that front end, and we call that control input validation. That means that we limit the syntax, okay, and the characters the user can use for input. We say you can only use numbers. You can only use the English language. You can only use the German language or the Hebrew language. Okay, you can only use this long, this amount of characters in this field, not more than that. So if I'm asking for social security number, it can always be numbers and up to 10 numbers, not 11 and not any special characters. And this will help me avoid problems or threats for just like the injection. For example, a big one that we're all familiar with is SQL injection. We have a SQL server on the database, and that SQL server has some sort of, has set commands that we can run against it. And since SQL Server can deal with big data, then that vulnerability is jeopardizing, compromising now big data anywhere in the world that uses a secret server. But it can still act the same way on other databases. For example, LDAP injection. There is also LDAP injection against Active Directory or any directory injection. Directory injection is big, okay, because there are many directories out there. So to avoid this, what we want to do is make sure the input mechanisms of the front end of the website actually communicate well and the way we want them to with the user that uses that front end. Okay? Any questions so far on this? All right, cool. Cover channels, a few terms that we need to remember, terminology here, just to understand the terminology behind the application security. Cover channels are hidden channels, and we've seen that when we talked about cipher and codes in cryptography earlier in this domain. Buffer overflow is the way applications manage their memory areas. The memory areas are big, and we talked about that before the break, and we want to work with programmer to raise awareness and to get them to manage the memory properly. The computer architecture, the way we build the program itself, the application itself, can include some of the principles that we already seen, the list privileges, the separation of privileges, and accountability, the audit trail. Okay, so anytime you work with programmers, with development teams, consider the logs as a big thing for security. You want to include not just the message for the developer team on a malfunction of the application, but also consider including information for the SOC team, for the security team, saying, I see someone, this can be a potential brute force. This error here has a potential to be a brute force. Somebody's pounding your database, trying to log in with the wrong password, wrong username. You should take a look at it. So not just the developers or developing team get their logs and get their troubleshoot process start, but also the security team. Okay, the security team can now trigger and have red flags everywhere because they get the right logs from our system, from the application that we build. So this is our role as CISOs, as CISSPs, to work with the development team to direct them on how to do what they do. Any questions on this, guys? All right. Next topic in your series is BYOD, bring your own device. We mainly talk about cellular phones, and we talk about this whole concept of, users use one device both at home and at work, and they get emails and sensitive information from the organization on their own private device, tablet, cell phone, whatnot. Today we have wearables, okay, the watches that we have, smartwatches that include sensitive information of the organization simply because they have WhatsApp groups and they have some sort of memory capabilities there. So the bring your own device is basically, both a business and a security issue. On one hand, we want the business to thrive. In order to thrive, a business needs speed. Okay, Bill Gates wrote a book back in the 90s. I don't know if you're familiar with this book. The name of the book was Businesses in the Speed of Thought. Okay, the way we think, the speed we think is the business is the speed businesses actually move. And this is a big one because businesses need efficiency and speed of doing business and speed of thinking and speed of collaboration and communication. So we want to invest in the speed. But if you remember when we started this bootcamp, we said, why do we have brakes in our cars? And the reason was that so we can drive faster. So in order for us to get the speed that we want to have good security controls. These are the brakes that we have. Okay, we have good brakes to drive faster, right? So in order for us to do BYOD and to provide the users the ability to work anywhere and to be mobile and to go on vacation but still respond to something and help the business continue even without them on-prem, there is a price for this. And the price on security can be big. Okay, now we share information on personal devices. So let me ask you, if my information is stored on your device, is it my information or your information? It's a big issue. Those issues can be addressed with legal departments and others, but the base says that, according to our policy, we should have a policy about that. According to our policy, when we take the BYOD approach and we allow users, we allow even the CEO, even the president of the company, we allow them to bring their own private devices, now they agree to the policy and procedures that we have in place for BYOD. And part of these policies and procedures say that when you use your device, you're enabling us to control part of it, if not all of its operation. That means that if you lose this device and you report back to us, we can remotely wipe your device. Wait, don't remotely wipe my device. I have pictures of my grandkids there, or my kids there, rare pictures of you know what? That's your problem, right? I want to allow the speed of businesses, and I want to allow you to bring your own personal device and not to impose my devices on you. You want the productivity, you want the ease of usability, fine, but there's a price for it, okay? The price in security always needs to be balanced with productivity, and that's exactly what we talk about when we talk about BYOD. For your CISSP, hang on a second, Shahar, hang on a second, just last line of thinking. For your CISSP, the main reason behind pushing BYOD as security professionals, as CISSPs, all right, is this one, this line here. I want you to mark it. It's not whiteboard, but just remember that we want to drive BYOD because it increases morale and job satisfaction of our employees. We want good spirit. We want culture of quick and production, but there is a price, and everybody should be aware of that price. Okay, Shachar, you wanted to ask a question.
In Germany, by the way, it's the completely opposite. Like, people prefer to have a separation between the private device and the company device. It's amazing. I've never seen something like this, and it also depends on the culture, you know.
Yeah, it depends on the culture, exactly. But you know what? If this is the case in Germany, then I would say being a CISO and having a BYOD policy is easier than in the States. Because in the US, it's the quite opposite. People don't want the hassle of two devices. You know, I need to charge this, to charge this. Whose computer is it? I want to have the same computer, the same laptop, the same device, the same cell phone working for everything I do. You know, and I take it with me, right?
Yeah.
And that causes another problem. You know, if
It's another debate. Yeah, I mean, it
right,
create additional issues. For example,
there
when
you
you're
go.
using 2FA, the people don't want to use their own devices for the 2FA.
Exactly, exactly.
Yeah.
So,
Yeah.
any questions on the BYOD guys?
No.
So is there any company in the world which suppresses this BYD to increase the security? Is there any company?
I guess that army or government.
Yeah.
Yeah.
I think in India there is a project called Bank of America where they are just developing some kernels. So in the project, as far as I know, they won't allow cell phones or cameras inside. Everything will be screened like the airport security in front of the cabins.
Yeah. Wow. That'd be interesting to be a CISO in that area, you know? All right, guys. Let's continue from here. Any other question on the BYOD?
No.
All right, cool. We talked about trusted computer. We talked about the way our systems are architected. We talked about open systems and versus closed systems. Let's talk a little bit about the environment themselves, okay? So for the environments, we can have centralized, decentralized, and distributed environments, which will then influence the way we manage our data. In centralized environment, this means that we have now one data center that all data goes to, stored, processed in, and then shared with. There's an upside and a downside for it. The upside for centralized system or centralized data management is that we need to invest only in one location. The downside is redundancy and availability. Okay, so there's a price for this. The decentralized means that our data center is now divided into 3, 4, maybe 6 data centers. Each one of them work with the other one, right? Obvious reasons, we want to have more availability, more redundancy. However, we now have 6 data centers. That means that we need to have a team in each one of them, right? And each one of them can act separately. So create more and more management challenges there. Distributed environment means, or distributed data environment means that now we have hierarchy. So we have 2, 3 data centers in globally spread organizations or technology. You have 2, 3 data centers, main data centers act as decentralized, but then we have data centers that speaks with them. So a city, maybe a country that holds a number of records, not significant number of records, communicates with that mothership data center and sees only that one. So in distributed, the little ones only see that big one and are not aware of the other data centers. This creates both availability, but a lot of management challenge, IT management challenges on that side. And again, the distributed environment can be a good choice for service providers, simply because you can route traffic from one data center to another. Consider this as you build and plan your environment. Internet of Things. Internet of Things or industrial systems or anything related to SCADA, it's all basically the same thing. We say that we can have data and we can have communication, computerized communication, basically anywhere in the world today. Okay? Anywhere in the world that has energy source, power source of some sort, and connectivity to the internet can become a potential target. okay? And it can be my laptop, my cell phone, my watch, but also my car, my refrigerator, lampposts, okay? We now have smart cities. So, I don't know, billboards, anything can become a target simply because it has data or data processing mechanisms on it and to the internet. So it's now connected to the big world. That makes it a target. So we need to remember that for IoT, we want to do more security on the perimeter rather than the device itself. So as we do security on the smart city as a perimeter, as a whole, rather than just secure every device, because it's endless. There can be endless number of devices today, and especially when we talk about IP version 6. Okay, so someone described the number of addresses we can give using IP version 4 versus IP version 6. And the description was, if I take all IP addresses in IP version 4 and write them down, and if I take all IP addresses for IP version 6 and write them down and compare this versus that, on one hand, for IP version 4, I will have a grain of salt, right? A grain of salt. And on the other side, for IP version 6, I will have the sun. This is the difference between the two. So as you can see, we are going in that direction. The world will switch, will move shortly, will move probably within the next decade or two to IP version 6, and that creates a lot of attack surface, a larger attack surface for us. A much greater headache for security people down the road next decade or two. We're not going to run away from it. This is where the world is going. So as we talk about Internet of Things, we also talk about SCADA and SCADA security. And what we need to remember about SCADA is the fact that SCADA are legacy systems by nature, right? These are systems that with a switch of electricity, they operate. These are pipes and these are elevators, and they don't necessarily have any IP or any IP infrastructure to work with. So most of what we're familiar with in our world of security today, we are familiar with the IT environment. SCADA is anything but IT. Okay, it means that I have a pipe here, and to open that pipe, I need to switch up that switch here 100 miles away from it. Okay, because it's a pipe of a dam of water, right? And I simply switch on that switch. However, that switch is part of a larger facility, and part of a larger facility using legacy systems that are from the 70s, are from the 80s, 60s, 50s. Back then, they didn't think about security. They only thought about functionality, okay? And for SCADA security, what we want to consider is the way that SCADA is communicated with the human. So HMI, human machine interfaces. We want to secure that part. We also want to make sure we keep the defense in depth concept, okay? So layered security. We heavily want to work with the people and with the organization to make sure we renew in time, we renew the legacy systems. We work with the vendors, okay? Vendors like Siemens and Mitsubishi and Intel can be a vendor of SCADA systems. We want to work with them to make sure we are in line of the latest technology, and SCADA systems are hard to protect. Any technology related to SCADA have different life cycle. If we talk about IT versus SCADA, IT will most likely run out of power engine on systems within 3 to 5 years. Okay, so back 5 years ago, 2015, we used Windows. We rolled out Windows XP. We started using Windows 7 heavily in the world. What we do today, 5 years later, we roll out Windows 7 and we start using heavily Windows 10. 3 years from now, we're going to ditch Windows 7, Windows 8, right? Early adopters within a couple of years will probably use the next Windows of Microsoft. That's what happens in IT environments. However, SCADA environments or ICS environments are vulnerable to those technology still being existed there. So we can still have SCADA facility or ICS facility, ICS-based facility, industrial control system-based facility, a power grid that uses Windows XP. Because for them, it takes about 15 to 20 years to roll out. It's not as easy, okay? Because this facility provides power. And we cannot update those systems as quickly as the technology runs or as quickly as the manufacturers are pulling out the support and services on those systems. Any questions on this?
No.
All right, cool. Okay. We will complete this chapter. We are on chapter 10. That means that after completing this chapter, we will complete domain 3. And after we complete this chapter, we will take a break. Okay. 15, 20 minutes, we'll see about that. And then when we come back, what I want to do with you between that return and our lunch break is that I want to practice with you questions. Okay. I want to take the first 3 domains, 1, 2, and 3, as we complete them, and I want to go over questions with you. Okay. So if you took the exam yourself, if not, if you took the exam yourself, perfect. This is a repetition for you. If not, you'll have the chance to practice and get the appetite of what it is, that is waiting for you as you practice more. Real good? All right, great. That last part used to be a domain by itself in the ancient CISSP before 2015. After 2015, ISC took it and implemented it as part of domain 3, which is security engineering, again, security controls. It basically speaks about physical security. Okay, so all the concepts that we have for technical security, for IT security, for security in general, logical security that we talked about so far, is also applicable here, right? For example, administrative controls for physical security. We can have an evacuation plan. We can have a site management. We can have awareness training for physical security. So any concept that we covered before can be applicable here. Technical physical controls are the technology controls we have for physical security. For example, alarms, HVAC, CCTV, and so on, right? Also access controls, the same thing. And then we have physical controls for physical security. By the way, this is my dog. Right? He becomes famous because it's all over the world. When I get to this part, I say, this is my dog. It's the same dog that was presented on the risk formula. If you go back to the risk formula, you see a German Shepherd there. That's real. He provides the physical security. I made this dog famous. So physical controls for physical security, fences, lampposts, dogs, guards, man-trap. Man-trap is when you have 2 doors, right? You enter this door and you cannot move on to the next door before this door closes, right? And as you move to the next door, this one is locked. So you can only go one way at any given time. Okay, you've seen that. You've seen that before in sensitive facilities that you probably visited, sometime during life. So the one thing that we really want to consider is the design of the facility, a design of the areas that we cover in physical security. We want to make sure people know where are the sensitive areas are versus other areas, because in sensitive areas, we need people to be more alert, more considerate of the requirements of security. However, when we mark these sensitive areas, we cannot say this is the data center, super sensitive data center of our company, because what we say is that we put target on that wall, on that door, and we don't want to do that, right? So consider marking your sensitive areas in such a way that will be understandable enough for your users, for your the employees, but not so easily to understand for others. And as you do that, also consider working with visitors, because you will have visitors in your facility. Visitors always need to be tagged or identified with a certain tag that is cleared for everyone. Everybody can see you from a distance, say, this is a visitor. Okay, this is someone that is not from my organization, even if I don't know them. And those visitors should be escorted at any given time. And the one thing that is super important for your CISSP exam is that you want to keep logs for visitors. The reason behind keeping logs for visitor is the first principle of security, first of 5, which is human safety. Okay, so if anything bad happens in physical security, let's say, God forbid, we have fire or an active shooter, that's a big one in the States, okay? We want to know who's in the facility. And we look at the logs, we look at the employee list, and we see that we evacuated all employees from there. Good, but did we have visitors? The way to address that is to look at the logs of visitors, right? So that's where you want to be. You want to keep logs for your visitors, especially in the CISSP. You want to show them that you got the human safety first and foremost before anything else. All right, so remember this. As you store your media, as you store your data on media, you need to consider a couple of things. First, the way you store your media needs to keep the data. So you want to put it in a suitable storage facility, so the data will not be affected or harmed in any way. But also, if you get to work for law enforcement organizations, for court or Ministry of Justice, for example, you want to consider the chain of evidence. Okay, so for media storage or evidence storage, you need to keep certain temperatures, certain areas with the access control. You need to bear in mind that the evidence, the chain of evidence, is very important for the usage of this data on that medium. There are some physical threats in any organization talking about physical security. First one can be the open secure doors. So open secure doors are a requirement by fire department and such to grant permission for the organization to work in that facility. You have to have those doors, emergency exits. Okay. However, criminals or those that want to harm your organization will probably look for these doors to break an entry into your organization. Since those doors need to be clear at any given time, okay, they will look for these doors as a vulnerability. So look at them, put some cameras there, put the alarm that when this exit door, this emergency exit opens, then it starts beeping and everybody's alerted to that. If it needs to be open, good, it's open. But if it doesn't need to be open, then we want to know about it, okay? That's the detection mechanism. We want to invest in detection there. Masquerading is when someone is pretending to be someone else, okay? So stealing the identity. And then piggybacking is when somebody is tagging or piggybacking on another person as they pass through security. Talk to someone at the entrance of the building and become friends with them. And before the security guard notices that, or that person that they actually talk to notices that, they pass the security guard and now they're in the elevator. They can ask someone to show them the way to the restroom. All right, something like that. That's a lot of social engineering there, both for masquerading and piggybacking. And we don't want to do that. We want to have those people authorized one by one as they go through the security guards. UPS in general is considered clean power for the CISSP. For security, for the environmental consideration, UPS still uses, I would say, the same shit as any other power facility uses, and even worse because it has batteries and acids and all that. That is very available for every one of us. But for the CISSP, UPS is considered clear energy, clean power, and if you get the choice in your CISSP question for the environmental consideration, choose UPS versus any external power grid or generator. Right? UPS is better. It holds less, but it provides the clean power that we want, and we want to keep the earth clean. some definitions in the electrical power world, we can have fault, we can have surge, burnout, blackout, spike. Spike is when you get a spike from the electricity as you connect a device or a computer to the wall, and then the spike in energy. I'll be with you in a second. And then the surge. The surge is again the high voltage. For a split of a second, you have that one. It can burn your machine. Yes, Alan, I'm with you.
Did you just say that UPS is the clean energy?
Yep.
But it's more dirty than standard energy from the
exactly
power
what I
grid.
said. It's exactly what I said. I said it's bullshit, but that's how CISSP wants you to think. If I'm talking CISSP, it's clean energy. If I'm talking outside CISSP, I'm saying it's worse, at least the same as any external power source.
It's not the same. It has battery inside and
battery, acid, you have all this stuff inside, and it's more accessible to a lot of people. I'd rather have this technology in the hands of those that can be responsible for it, and not as accessible for everyone, so they can throw away the batteries any way they want. Right? But again, we're here to pass the exam. Valentino, I'm with you.
But I think what they mean about the clean energy is the fact that the level of voltage stays the same when it comes in and goes out.
Yes, you're absolutely right about this.
Because coming from
always the same, so you will not have this powers, this problem, right?
So the source of your electricity is always clean. I think that's what they actually mean by clean energy.
Not so much, because if you read the book, you'll see that they encourage us to use batteries and UPS because it's cleaner, keeps the environment safe, and we will get to the Halon gas shortly, and we will also speak about the ozone layer of the world. Okay, so yeah, CISSP is, there are some areas that are bullshit, but it is what it is.
Idiots.
Tell that to the kids that mine it in Africa. It's not clean.
They just make more money.
Yeah, it's another way of making more money. You're right. All right. Here we are, environmental and life safety, exactly what we talked about. Okay, for the environmental safety of our the areas which we have, our systems resides, data centers and such. So we need to consider some areas, for example, humidity levels, and high level of humidity will cause corrosion in the systems. Low level of humidity will cause static pulses. What's that again?
Static current.
Static currents. Yes, thank you. So we want to consider different levels of humidity and also the air quality that we use in those facilities, in data centers. The first and foremost that we will need to consider in any environmental question that we will get on facilities is basically human safety. Okay, people's safety. So as you get those questions, the state of mind you need to be in is how do I save life? How do I make people healthier? Okay, this is the state of mind that you will need to consider as you address those questions. And then you have some areas that you will need to think and remember. For example, the temperature of rooms containing systems and computers should be 60 to 75 Fahrenheit, which is 15 to 23 Celsius. ISC is playing with you, right? They're not on your side. You're on your side. You care about you. So look for the pitfalls. Read the answer, because I've seen and I've heard about it more than once that they put 15 to 23 Fahrenheit and 60 to 70 Celsius in their answers. Level 1 type of questions, okay? But don't fall for it. Read through the question, read through the answers. 60 to 75 Fahrenheit, 15 to 23 Celsius. Humidity should be between 40 to 60%. Anything above that will cause corrosion. Anything below that will cause static currents. All right, static electricity. Now we move to fire hazards. Fire hazards are big. Okay, they can cause, electricity to go bad. The smoke can affect your electricity. But the first thing that they cause is probably danger, threat to life, to people, and that's where we really want to deal with it. So with fire type questions, the first thing that maybe the only thing, 90% of your consideration is to look for the answer of people's safety. Okay, fire equals people safety. That's where you want to be. After this, everything else happens. Okay, so after we saved everybody and we evacuated everybody and we don't have any danger of people getting hurt by the fire or by the smoke or by anything, the gases and everything, now we can move on to electricity and to understand that the smoke of the fire itself can affect the electricity, the electric circuits that we have, and the technology that we use in that place, in that data center. So for that reason, we want to put smoke detectors. We want to put heat detectors. We want to use technology to detect the problem, detect the fire. And as we detect the fire, we want to address it. We want to correct it. So the correction, part of the correction will be to use gas, extinguishers against the fire, against the potential fire. So back in the days, we used halon gas. Okay, halon gas, it suppresses the fire quickly. It takes good control of the fire. However, it's very dangerous. Okay, it becomes toxic when it reaches 900 degrees Fahrenheit. And for this reason, we rule it out and we're not allowed to use it anymore. Right? So instead of using halon gas, we use much friendly gases today. So if you get an answer on halon gas, very remote possibility that you will get a question about that, know that halon gas is toxic, and halon gas is toxic on 900 degrees Fahrenheit. It was ruled out back in 2003. Regulations against it. We don't want to do that. We want to use environmentally friendly gases, and there are other options there. Again, this can be a really remote possibility that you will get this type of question. I assume that if your exam will take you toward the 150 questions, you'll probably get a lower level question. For example, that halon gas can be part of it. So again, smoke and fire, first we want to detect, we want to put detectors there, then we want to suppress, we want to control that fire. And how do we detect that fire? We use sensors, heat sensors, flame sensors, smoke detectors, and such in order to alarm us. Those will not control the fire, right? Anything else that happens after the detection will probably take control of the fire. For example, the fire extinguishers or the fire classes that you can see on the fire extinguisher. You can see this on every fire extinguisher in the world. This is a global language. So for class A, we're talking about common combustibles, right? That's wood products, that laminates, and that fire extinguisher will mark, okay, I can deal with class A fire, right? Class B fire speaks about liquids. For this one, I will need a different extinguisher, or if that extinguisher can be used against liquid, then it'll show that the B class fire is also covered in that extinguisher. The same thing for C, which speaks about electrical equipment, electronic equipment, and such. And last one is combustibles such as metal. Metal you can find in big factories and such. For those, they have different fire extinguishers and fire suppression systems for them. Okay, so class D is for the combustibles. Now, in order to suppress the fire, we will need to use some sort of liquid, probably water, but others as well. So the concept behind controlling the fire using liquid is that we need to have enough liquid, enough water to use to suppress the fire, but not too much that can kill the technology, okay? Because water and liquid and technology don't go together, okay? So for this one, we have two different technologies. One is called wet pipe, and the other one is called dry pipe. The wet pipe says that, you know, up until your sprinkler up in the ceiling, you have a sprinkler, you have water going up all the way up to that sprinkler, and there's a little ampoule there, plastic ampoule, that will melt in case of a fire, and this will trigger the fire extinguisher to go, okay, the sprinkler to go. This is the wet pipe. The water gets all the way up to the ampoule, to the exit point. The dry pipe says that I still have the sprinkler, okay, and the ampoule and all, but the fire don't go all the way there. They're in the back somewhere waiting for another mechanism to go and operate. So the ampoule breaks. It takes a couple of minutes before the water can come and get through the sprinkler. This gives me time to say it broke for no reason. This is false positive. So I can shut down the water system. All right? Are we good there? So this is dry pipe versus wet pipe, okay? And the pre-action is exactly that, exactly what I just described for the dry pipe, okay? So remember this, that it can provide us some time, can give us some time to control the water or the fluid extinguisher. Now the deluge is big ones, big amount of water coming out at the same time. I think not too long ago, one of the hospitals here, I think it was Rambam in Haifa, had a problem with their fire suppression system, and the big pipes of fire suppression. It was a malfunction of the system. Detected fire. No fire was there. The hospital flooded, 1 meter height water for 3 days because they used deluge systems. They used flood. So it detected fire and triggered the flooding system. And that one triggered or released a large amount of water. So you really want to consider controlling those systems properly. When we talk about fire extinguishers, we can talk about water or wet fire extinguishers, which include fluid, but also gas extinguishers. Those will be marked on the extinguishers themselves. And the key to security with fire extinguishers is to mark those areas. So consider, as you answer the CISSP questions, talking about fire extinguishers, consider the location of those extinguishers. They can be located within 50 feet of any electrical equipment. So if my data center is here, I want to have the fire extinguisher at the entrance of my data center, not too far from it, and I want to mark it. I want to make sure people actually see it. And that fire extinguisher needs to be regularly inspected by law enforcement. Okay, so if no law enforcement contact me, then I need to contact them and initiate that audit on my fire suppression systems. And then last but not least, for security, physical security, that chapter, are fences. We talked about fences, and there are a couple of standards for fences. So for standard security in a facility that is considered secured but not top secret, okay, it's all about classification. We want to use 6 to 8 feet tall fence with one barbed wire. How do you say it, Takari? One barbed wire line, okay, on top of the fence, just like the picture that you see here. For more sensitive facilities, the fence should be higher than 8 feet, and then 3 barbed wire lines on it, just to provide that level of security, because it depends on the sensitivity of the facility. If this is right or wrong, I don't know. But these are the standards of ISC. These are the standards that we need to remember as we enter the CISSP exam. All right, guys? Okay. I know that the physical security contains a lot of information that we need to remember, numbers here and there. It's not too bad. I assume in your exam, Shachar, in your exam, couple of questions around physical security. Right?
Taking you by the word.
What's that?
I'm taking you by the word.
By the word, yes. So two, and in worst cases, if you get to 150 questions, they can ask more. So I would say 2 to 4, right? 2 to 4 questions. In good cases, you will get 1 to 2. In worst cases, as you pass the 110, 120, you probably get a couple more, right? Because it's tricky. They can fool you there, but it's not as important. Okay, human safety is big, all right? Any questions on this?
No.
All right, cool. All right, so let's take a 20 minutes break. All right, we'll reconvene at 11:40. Let's make it 11:45. All right, and and as we come back, we're going to spend about an hour solving some questions. All right, sounds good, guys.
Yeah.
All right, great.
Yes, thank you very much.
All right, I'll see you
Bye-bye.
soon.
Yeah.
All right, bye bye.